keep on reminding you that you're mine. You're gonna wife me, and I'm hanging in the backseat, and I'm waiting for a chance to say bye. 'Cause we've been waiting for love that is real. And even when we try to throw this all behind, I find myself inside of your arms again. What if I'm insane and taking me for granted? I would never come to forgive myself. 'Cause I ain't tryna be your ex, so don't call me if you wait. Tryna vibe on my way, I'm on top of my game. I'm on my way, yeah. So don't call me if you wait. Tryna vibe on my way, I'm on top of my game. Hanging in the backseat, hanging in the backseat. I'm on my way, I'm on my way, I'm on my way there. And even when we try to throw this all behind, I find myself inside of you.
Hello, everyone. I hope you can hear my voice clearly. Welcome, welcome. I'm Leikun. Nice to see everybody here. So excited to walk through today's session. And yeah, I want to know if you guys are doing well. The week is treating you as good as it is treating me. I just want to know like how you are so far. It's the middle of the week. You've been going through your projects. So how are you guys doing? Just mention it on the chat. You can use emojis. You can use your words if you want to. If you want to also unmute, you can ask me to unmute you. How's everybody doing? Nice? Good? Bad? Exhausted? Happy to be here? How's everyone? So I'll tell you mine, maybe, just to break the ice. It's the middle of the week, but it feels like it hasn't yet started for me, which I think is good. It's a good feeling because I have a lot of things that I wanted to accomplish for this week, both personal stuff and also work related. So yeah, that's where I am. I've not yet burned out. Hopefully that doesn't happen until the end of the week. So that's where I am. So how are you guys doing? I see about like 47 people who joined us. I'm also sure that you can hear me clearly, I think. Oh, John Kamal, you're in Prodev BE. You're here also. Interesting. Nice to see you here. Oh, awesome. This is so good. Doing good. Awesome. Abraham, nice to see you here. Yeah, awesome. So I hope you don't burn out as well throughout this week. Comparatively, this week's project, I think, is not that bad, right? And also Python is very cool. It's a very, very easy language compared to the others. I mean, speaking for myself at least, I started off with, I think it was C++. The first time I touched code, it was with C++ back in the university. And then I moved on and tried some Java. It was so confusing for me the first time. And then the next time I touched code was, I think it was in Excel. I don't know what the language is even, what like language they use in the Excel program. The next one is Java. No, not Java. It was JavaScript, sorry. It was JavaScript and then I think that's, yeah, just after JavaScript, I moved back to where I started, but even farther with C when I joined ALX, and then going to Python and then JavaScript, Node.js, then the rest is history, right? So From all of those languages I've ever tried, I have found Python very easy. JavaScript is very nice. It's everywhere, so it's great. But Python is the most like closest to English, right? It's so easy to work with, and that's why also most libraries are built off top of um, Python. I see some people here are from also like the backend, the product backend side, which is great to see. And there we used the Django web framework. So you guys may not be familiar with it. Maybe you've heard of it before. So it's just a web framework. So it's a very, very versatile and ubiquitous language. So yeah, the Python weeks, they're gonna get exponentially, not exponential, but just gradually harder and harder. But you can rest assured that it's just Python. You just have to think that it's Python and you can do it. The rest of the stuff, of course, you'll have to understand very deep. Okay, it's nice to see everyone here, and most people actually joined us. So yeah, today I'm joined with John and some of our team members as well here to help you out to help out on the background stuff. So thank you, team, that to be here and helping me out throughout this session. All right, awesome. So moving on to the rules of engagement. So if you got any questions, we have the Q&A section on this webinar. You can put your questions there, and some of our team members and also me will be sure to take over and answer those questions. If you want to ask them straight live, you can raise your hand. Maybe you can ask to be unmuted. Post them also on the chat if you want to use the chat as well. I'm keeping an eye on the chat. Feel free to use the chat liberally, but be respectful to your peers, and then listen, learn, and engage. I hope you also open up your Jupyter notebooks on the side while this session is going. It's a 2-hour session, so just sitting around and listening to it is not going to do you any good. You should do the stuff on the side, also trying to keep yourself busy throughout the time. All right. All right, I'm not sure here if we have, yeah, we do have Segun, who is our amazing mentor here with us, who, if he can, maybe like he can walk us through the resources for this week, the assessment guide for the integrated project. So, hey, buddy, are you there?
Yep, I am. Yeah, I'm your sidekick for today. Your Batman, I'm Robin today. All
Awesome.
right. Good day, everybody. My name is Shegun Lawal, and I just want to walk you through the code challenge guide. Yeah, like, can you zoom in a bit? Yeah, good, better. So yeah, we created this guide for you guys to assist with any technical uh or any issue you have with the assessment. So it is a project and an MCQ. So it's not a code challenge, though you will write code, but you're not uploading any code to Athena or for the auto grader. So you will get your notebook and get the data, the database and everything. Then you work on the notebook. You do all the code and the questions they ask. Then based on the code you write, you will use the answers to answer the MCQ. Okay. So if you see this error, you see any error, the type error is query must be a string unless using SQL Alchemy. It simply means that the version of your SQL Alchemy is a lower version as compared to what's required for this. If you remember in when you're trying to connect your Jupyter notebook to Anaconda, you had to use an older version of my SQL Alchemy, I think version 1 point something. So that version will not work for this part. So you need to upgrade it, right? Can you scroll down a bit? So if you get that error, just run this code print SQL Alchemy version. If your version is 1 point something, it means you need to upgrade your version. Just create a cell and run pip install upgrade SQL Alchemy. Then you restart your kernel and it should be fine. Okay, good. So for this code challenge, when you download the margin dogo farm survey small.db file, make sure it's in the same folder as your Jupyter notebook, right? So when you download the small.db file, if the file is not 1 MB, the file from Athena is about 2 something kilobytes. Don't use that file. If you use that file, it will affect your answers and it will affect your MCQ. So when you get this what do you call it? When you get this guide, just click on the download button here. Click this download button to download the new margin dogo file.db. Yes, just click on it and it's just a download link. Once you click it, it will just automatically download to your computer. Like you see, Elokun is clicking it, it will just download. And yeah, once you just click it, it will just download. And Lekun, can I see your downloads? Yeah, can you check the size of the file? It should be 1.1 MB.
Yes, it is.
Okay, good. Yes, good. So if you have this margin dogo file and it is not 1.1 MB, it means there's something wrong, so you need it. Lekun, is it possible to share the link on the chat for the learners?
Yeah,
Good.
I can share
Just
it.
share the download link so that, or better to share the link of the guide.
Yeah,
So
I will.
they have all the material, not just the download link.
Yes.
Good. Just share the link of the guide on the chat so learners can quick class. But yeah, you guys will get this link when you get the notebook. So that's it for the data set. Then for the assessment, when you open the assessment, some of you will have issues on opening the images, right? Leko, do you mind clicking the link to the images? MCQ, good. So some of you, when you try to do the assessment on Athena, some of the images may not load. And two of the questions, I think question 1 and 9 has images. So we have observed that some people, because of network issues or connection issues, the images don't load. So if you have that problem, we have the images here. Just click on the link and you'll see the images to question 1 and question 9. So you can't answer the question without the image. You need the image to answer the question. So if you're having problem loading the image on Athena or your browser cannot load the image, just come to this guide and you get the image, okay? Like, can we go back to the guide? All right, good. So like, you can scroll down. So below this part, we have an extensive walkthrough on what you're supposed to do and everything. It's easy to read, to understand. You can technically do the assessment without the guide, but if you are having any difficulties understanding any concept or what you're supposed to do, just go through this guide and it will walk you through everything you're supposed to do, every concept, everything that you're supposed to do for this assessment or this code challenge MCQ. We have it here. It's easy to read. And yeah, feel free if you have any more questions to reach out to us on AnswerBase or eHub, and we'll be there to respond to you. Okay, that's it from Robin, and I'll pass it on to Lekun. Right.
Thank you, Saigun. Thank you so much for that deep dive. Awesome. So also note that we will be sharing this for those of you who are here. You should have access to both the documents and the chat. For those who are not here, they will be shared on eHub. So don't worry if you're looking at the recording of this session. Awesome. Okay. Let's move on to the next section, which is the main one. Okay, so for today, we are going to be focusing on 3 concepts. 2 of them are actually similar, so separating them may not have been a good idea, but it's okay. So start off with regex. Takes just slightly longer time to go through the matplotlib and seaborn because we have to understand some like statistics related. Oh, my voice is very low. Okay, I'll try to speak below star. I think that'd be a good idea. All right, okay. So yeah, starting off with regex and moving on to the meat of today's session, which is matplotlib and seaborn, which is basically visualization. So that's what we are going to be looking at for today. Right. So let me open up my my Node Jupyter Lab URL here. Yeah, I think this the one. All right. Okay. Yeah, this is the one. Awesome. So we're gonna get started with regular expressions. Regex basically means regular expressions shortened to fit the speaker's mouth, I guess. So imagine let's say you're working with a massive environmental data set. So you have like thousands of field notes from conversation volunteers, let's say. And some notes contain about like hashtags that looks like hashtag endangered species or hashtag keep Africa wild, etc., etc., etc. So other notes mention specific metrics like, let's say, found 47 elephants or logged like 12.5 acres of land, right? So how would you be like able to like use find and split to extract all of these? So you need to write a lot of code, a lot of Python code to just be able to like extract those values by using conditionals, right? It would be like multiple functions. Sometimes you might have to maybe try to create even classes to go with them, right? And to get the exact value. And even then, the function may be very, very niche and it may not include a long variety of texts that you want to match, right? So with regular expressions though, what you do is just you write one pattern and that matches all the hashtags or all the numbers. And then you're good to go after that. So that's just an expression. So it feels like you're learning a new type of like language. But once you get used to it, the beauty of regex is it can be used in multiple programming language, not just only in Python. You can use it everywhere because the structure does not change throughout, right? So you can use, for example, email validation, check if someone's emails is a valid format, phone number parsing from the data that you have in whatever format that you'd like, web scraping, like pulling data from the HTML and you want to strip out the HTML tags from the HTML page that you've downloaded, data cleaning. If you have a messy text, then you can basically clean it. And big data processing like Spark, Hadoop, and Kafka, all of them actually use regex internally. So let's start off. So there are two types that we can use. So you can use like literal characters, and you can also use like case sensitive formats for your regexes. So in the simplest form, what you can do is Python has internally the RE, regular expression package, which has multiple methods that you can attach to it and extract text out of. So for example, if you, let's say you want to find within a text the word Python, and you don't mind how it's spelled, as you can see, this text is actually has about like 4 Python occurrences. The first one is just first letter capitalized. The second one is all letters capitalized. The third one is not, like it doesn't make any sense like how it's capitalized, right? These types of things might happen if data sometimes is pulled or like scraped from the internet, right? In which case, if you can use the RE classes find all method, and you can give it what you want from the text and the text itself that you want to scan, right? In which case, if you return the matches, I think I have to first, no, that's okay. I can just play this one. The matches that you find are basically lists, right? And then this is the match that you get, right? So it says match for Python. This is a literal type of match. which you are just giving the word Python to be searched within the text. This is the simplest form of regular expression. You're just searching. For this, you may not need regular expressions, of course. You can just do this test using includes. But later on, when you see more complex types of matchings that you want out of a string, then it becomes very hard to use just Python. Okay. So how about like case sensitivity? So notice that the pattern is actually just only Python with all small letters, and only match the lowercase version. So here we have a lowercase only version, and that was the only thing that was returned. Anything else was not returned. We did have 2 or 3 of them, right? So how do you also take note of the case sensitivity and ignore that case? Well, RE is like it has more attributes and methods that you can use. One of the attributes is ignore case. You can add that as a flag to the re.findAll. For example, if you want elephant from this text, you have how many elephant in here? 1 and 2 and 3, right? In which case, all 3 of them should be matched if you use re.ignore ignore case. Notice that we start first with the regular expression here. We gave it the text that we want to search from, and then what flags that we want later on, right? So this is how you use it. So if you just play this one, you'd see a list of matched elements. So notice that the first one here, elephant and elephant, is only found from the first one, this one, because we did have 2 of them here matched, right? But on the third one, since we included ignore case, then we can actually match the capitalized version, right? Just take note of this first. Okay, now let's talk about meta characters and character classes. These are important characters which are not going to be literally interpreted when you use them as regular expression in findAll or any other methods that RE provide. So these are, for example, the dot, the upward arrow, arrowhead, the $sign, and the backslashes, the 2 backslashes. This is used to escape. It itself will not be used literally in the regular expression, right? However, it can be used to escape the other characters, right? And these are the meta characters. So the dot is any kind of single character. Just take note of this. Dot is any character. Of course, except the new line character. So the new line character is basically this one. For example, I can just say print here, and I can do backslash n this, right? So this is a new line character, right? I think this has to be, let's say, yeah. So there's a new line here that cannot be seen, right? You can see that also if you want to use triple quotes like this, and then a new line and then triple quotes. If you play it, if you run this, you'll see the literal character of backslash n, right? When you print it out in Jupyter Notebook. So these new line characters are characters themselves, just one single character. Even though you're seeing / and n, that's just one new line, right? So that's not matched by this dot, but everything else will be matched. This caret character is the start of a string, right? You denote this as a start of the string, but by itself, it doesn't mean anything. You have to add some stuff after it for it to have a meaning. For the $sign, this is to match end of a string. You have to precede it with something else. So the first one, the correct one, oh, you cannot hear me. Okay, is it the same for everyone? I'd have to speak a little bit closer to the mic, or maybe, okay. Okay. Oh, I see. Okay, my voice is low. Okay, good. All right, I'll try to speak louder. All right, where were we? Okay. So this dollar sign right here, we will see later on how we can use it. But know that it has to be preceded by other characters for it to have a meaning. And this first one has to be the first character before any other characters come to be able to like match the stuff, okay? Okay, and there is the core character classes here. The \d, which is the small d, that's for digits. 0 to 9 would be matched if we use the \d here. The capital letter D will be for anything other than digits, so non-digit characters. Small letter W will match every word, and that will include, make sure that you understand this very clearly, it will also include digits, all right? So if you use \W, you can rest assured that digits will be matched as well. These are, by the way, single characters, okay? So A to Z, this is A to Z, small letters, capital letter A to Z for capital letters, and 0 to 9 for numbers. And one last one is the underscore will also be matched by this word character class. Okay. And the capital letter one is it negates it, and that means non-word character, anything outside of these, which means basically symbols and spaces and all that stuff. Not spaces. Spaces comes next here, which is the small letter s. And this matches any type of white space. White space include spaces, the normal space on your keyboard, a tab character, which is the tab character on your keyboard, and a new line character, which is your enter key, right? All of which they can be denoted using, let me show you here. So a normal space is just a space like this, right? A tab is going to be \t, like this, okay? A new line is just going to be a new line like this, right? So you can use all of these combinations. For example, in the second turn here, what I can do is I can just use f string in here. Yeah, let's use f string, but this is an expression, so we have to put in curly brackets within. Make sure, and then here I can add a \t to print it, and you can see there's a tab character right here, which pushed all the text to the right side, right? So this is what we call a white space, right? I can do a new line also if I want to, in which case I'll add one more new line, as you can see here. And the space is just a simple space, right? Simple space would be added here. So these are called new line characters, and they all will be matched with the character, right? All right. Yeah, and this one, it negates it. So let's go on to all the exercises here. Extract all digits for this example, right? We have digits in here, right? 15, 23, and 8. Now we want to extract those. How do we do that? Well, we use the digit extractor like this, which means, by the way, this is just one character, okay? But here we have like two characters, right? So the output of this is going to be all one letter digits, like 1, 5, 2, 3, and 8. It doesn't mean 15, 23, and 8. Okay, just take note of that because this is just one character. The second one, find all words. So all the words are going to be returned, which is all words. And then it's not going to include this symbol. A parentheses is a symbol, right? It will not be included. Instead, it will include word characters in groups, and anything else will be ignored because we're using W. And then the plus sign, we'll see later on, that means one or more characters, right? One or more word characters, which means it could only be W, or it could also be like WORD, right? But if it includes space, that's not matched because space does not work with this character, okay? Finding a white space, you can find the white spaces. So if we print this one, you notice we have 1, 5, 2, 3, and 8, and we didn't have 15, 23, and 8, right? Makes sense? For the words part, again, notice that what happens here is we're extracting the full word. As I said, the digits will also be captured, right? So that's what it captured, the entire digit, right? Here also the entire digits and all the words. Okay. All right, I think that's good. Let's go on to quantifiers because we don't have to waste a lot of time on regex only. So on quantifiers, this lets you like use the character classes and build on top of them. We saw earlier the plus sign, how we can use it, right? I think there's also one above here. So the way you use the plus sign here, it means, for example, these are basic quantifiers. So for the plus sign, if it's preceded by, let's say, a character class like this, that means one or more times. So what this one means right here, right? So if I just go in, what this means is there's going to be one digit, right? 0 to 9 is going to be matched. But I'm saying, okay, so one of that digit, if you find one digit, that's okay. You can match it. But also if you find other digits which have more than one, like digits stacked between each other and with spaces around or some other type of character, then match those as well. That's what I'm saying here. In which case, if I have maybe like 45 here, 45 itself will be matched because we have two characters, right? This is one or more, so we have two characters, 45 would be matched. And for this one, you notice that I have 1, 2, and 3 surrounded by non-digit characters, right? So those will be omitted and 1, 2, 3 will be matched because it's 3 characters, digits, sorry, right? So we can extract the numbers this way from strings, right? That's how this works. So you can just play this from this. Yeah, it's 1, 2, 3 is matched, 45 is matched, 456 is matched, 78 is matched. So you get the idea, right? And on the next one, non-digit characters can be captured here, right? So that's how you use this one. Okay, but for the quantifiers part, we just saw this one, right? One or more. Now the asterisk sign, that is for 0 times or more times that can happen, which means if I did that here, I would mean, no, so there is no digit, in which case match that. Or if you get one or more, then match that as well, right? If I did this one, right? So what does that mean? If there's no digit, then it doesn't matter. It matches it, right? 0 digits. It's matching like these empty strings right here, like empty spaces, right? And it's matching also the numbers as well, as you can see, right? It's not very useful. You wouldn't actually use this like in this format, but the asterisk sign is very important. The third one for the basic quantifiers is the question mark. That means 0 or 1 times that character can happen or can be matched. Sorry, can be matched if it shows up 0 or 1 times. A character can be matched 0 or 1 if it shows up 0 or 1 times, right? So for example, this is a very good time to maybe like tell you about like how we can use match the two words, which are like let's say words. I can just say color as the Americans say it, and color as the British say it, right? So the way you can match color in both cases color or color? Just a question, right? If you want to match this, you do rd.find all. And then the regular expression, one thing that we haven't mentioned as well, that I alluded to, is this R character before the string itself. Okay, this is a very important one. If you're using a non-literal type of regex, like this one, this is not literal character or word, you have to use R here. So R followed by an empty string for the regex, and the one that I want to match is words, right? So what do I do here? Well, I want to match both of them, both occurrences, right? So what I will do is I'll use color like this, but you might exist, right? So, it might or may not exist, in which case I'll add a question mark after it. So this means you can be omitted, that's okay, but it can also be only one time, and then in which case that should be matched, right? So if I play this, both of them are being matched, as you can see, right? If we have though here, if we add color, like with a typo, we wanted to say only one U, but we had a typo here and we added two U's, this would not match this one because question mark means 0 or 1 times, right? So this is a good time to ask you guys, how can we also match this color word as well? How do you think we can match that one? You can use the chat or maybe like unmute if you want to. So the question is, I already am matching using this regex here, color and color as the English say it, right? But I also want to match this third one. So what should I do now? We already have seen the basic multipliers, haven't we? So what do you think I should do? How do you think I should change this regex so that I can match also this word? Okay, John says you can add this and this together. Okay, we can try it. Interesting, it worked, right? What other ways that can I use this? There seems to be a redundancy here. It works, however, but like it seems to be like redundant. So I can also remove the question mark, right? There's no need for it because what I'm saying here is you and asterisk. What that means, what that tells Python is so you can happen 0 or more times, right? In which case that will be matched, which lets me also handle, by the way, other types. Like I can add as much here like this, and that would be matched as well. Okay. So yeah, that's how you would use asterisk and question mark, right? Okay. The other one is, okay, I'll go over it once more. Let's remove all of them back to where they were. So this is what I did first, right? So let me just maybe comment out everything here. Let's comment these out. Right, so my intention here, let me play this one once more just to see output. The intention is, so this is a word or words that I want to match, right? In here I have the English way of writing color and, no, sorry, the American way of writing color and the English way of writing color. And in this case, I don't mind the spelling. I don't mind the spelling. I just want to have I just want to have the meaning of the word, let's say, right? Let's say I'm using AI for this, right? In which case I want to match these, both of them. Both of them mean color, right? We know this, but there's a spelling difference. So I have to match both of them. Now, to match both of them and return them as an array like this, just see how many times it's occurring, what I'm using is the question mark here. The question mark means the preceding character, which is you here, U is the preceding character, that can happen 0 or 1 time. So 0 times, it would match our American way of spelling color. 1 time, that would match our English way of writing color, right? So this works perfectly for my use case here. But what if the word or the sentence has some kind of a typo, because I'm just getting it from, let's say, a speech recording or a transcription service that uses AI, and it's making some issues. Or it could also be a web scraping issue, right? And I have like this type of color, right? I want to also match this. Maybe later on I want to change this to the American way or the English way. That's the only reason maybe like I might want to match this. So this does not include when it tries to match it, it will not include past occurrence, which is a typo, right? But let's say I want that typo. I want it to be matched. That's what I wanted. And John mentioned I could add an asterisk just after the U character. And also I can have this one. That works. However, the question mark is redundant, right? It can also work with asterisk. So asterisk does 0 or more times the preceding character can show up, in which case I'll match it. That's what it's telling the class or the method find all, right? So U is the preceding character. It can show up 0 times, in which case the American way will be matched, 1 time, in which case the English way of writing it will be matched, or more times, in which case the typo would be matched as well. I hope that makes sense. Awesome. All right. Apart from these basic quantifiers, we have specific quantifiers. These give you more control. So this is 0 or more times, this is 1 or more times, but what if you want 2 or more times, or 2 to 3 or 5 times, right? If you want like a range of values. That's when you use these curly brackets. So n represents the number of occurrence of the previous character, right? So exactly n times that can occur. Just to see that, or let's finish first actually. The second one is n and m, which basically means including n and m times, or between those two, including n and m, the character can be shown. In which case, match that. That's what we're saying here. Or the third one is n or more times. So this is kind of like the same as 1 or more time or 0 or more time. But here you can start with anything above 1 as well, right? So that's what this one gives you. So n or more times. Just to see this in action, for example, if I want to match only the typo that has 3 U's in the word color, which is basically a typo, right? What if I want to do that? I want to match only that typo, in which case I'll go ahead and use curly bracket here and give it the value 3, right? So U, that's 3. So if I run this, that typo only would be matched, okay? What if I have, let's say, for 2 U's like this, and 3 U's as well, right? So if I want to match typos, any type of typos that have duplicated U's multiple times, it could also be 4 times like this, and I want to match all of these typos, what I can do is, maybe like, let me give you as an example, how do you think I should rewrite my regex here to match all of these 3 typos? And take note that we have 2 U's on the first one, 3 U's on the second one, and 4 U's on the third one. So I want to match all 3 of them. How do you think I should change this regular expression? So take note of this one. You can use the chats if you want to write down the regex itself. So I'll wait for you guys. Okay, Samuel says, I can use the third option, which is this one, right? Exactly, that's what I can use here. I can start off with 2 and comma, and however many times U can happen, please match that, right? In which case, if I play this, all the typos are matched, right? If I want to be very specific and I want to only match these 2, for example, or maybe like the last 2 here, what I can do is give it an option for n to be 3 and the maximum only 4, right? In which case, this would not be matched because we only have like 2 u's in front of it, right? So if I run this, these are the only things that I get returned. So we've seen all 3 of them. We've seen the quantifiers and the specific quantifiers. Great. I'll be sharing these notebooks that I've created while I was preparing for your session with the team, and it will be shared with you guys along with the recording of the session, I hope. Okay, so don't worry. If you need anything, I'll share it with you. All right, okay. All right, so how about greedy and lazy matching? So by default, regular expressions, quantifiers are greedy. Quantifiers, basically we saw them, right? So basic quantifiers and specific quantifiers, these ones, they're greedy. What that means is they will match as much as possible, right? They match as much as possible. So for example, if I add a question mark to make them lazy, then they match as little as possible. Okay, so question mark limits the greediness to be lazy. Lazy matching, right? Not greedy, but lazy matching. So let's see that in action. For example, asterisk, right? This means 0 or more times that will match, right? Which means everything in here will be matched, right? Which means here I'm using A asterisk, right? Which means 0 or more times, which means C and T can be matched because this means 0, right? 0 A's. There's no A's in here, in which case it will be matched. So everything here will be matched in this case, right? That's greedy. So if I play this one, all of them are matched, right? True. All of them are true value, right? On the second one, 1 or more. So the pattern is this one for the cat. If I see this, 1 or more means C and T, this will not be matched. Everything else will be matched, right? So if you run this, the last one would give you a false value for C and T, right? All right, example 3. So optional, you can use optional and N. So the pattern is color again, the one that we saw earlier. So here we're saying, so pattern, okay, this is, this one, sorry. It will match both of these, right? We know this. 0 or 1 time you can happen, it will match both of these. Another pattern that you can use is a digit with a, what is it called? This specific quantifier, right? So how many digits? Basically, this is like 3 digits followed by a dash symbol followed by 4 digits. So this will match this and this one, right? In the case of this one, right, specific quantifier, the digit can be in between 3 and 5, including 3 and 5, right? In which case we begin matching this one, the third one, and the fourth one. The rest is not going to be matched, right? So like the aha moment for greedy and lazy matching, I think let's just run this just to show you, right? Color and color, both of them are matched. And here you have like 3 as the first one and 5 as the last one that's being matched. So yeah, that's what we just talked about. All right, so greedy versus lazy matching. Let's see this one. For example, let's say you scraped a website and you got these characters, which are basically HTML tags. Now, if I match these using the following regex, right? This regex, what does it exactly say, right? It's when you see it first, it becomes very difficult to know it. It feels like a very cryptic, right? Symbolic and stuff. But just like if you look at it like symbol by symbol or character by character, and you understand regex, at least the basic, and you have the basic understanding, then you get to know like what each thing is doing. So you're good to go. Okay. We talked about last time what a dot is, right? A dot is just it matches a single character, but it can be anything other than a new line character, right? So when we see this in a regex, we'll put that in our mind. Okay, so this means a character. Oh, there is a plus sign just on the left side of it, on the right side of it. Oh, that should mean, so any character can happen just once or multiple times. That's what this means, these two combinations, right? But again, it's not over. They are enclosed by angle brackets like this, right? Those two angle brackets in regex, normally they don't mean anything. What they mean is just literal characters, just like A, B, and C, okay? Don't worry about them. It's like, they're not special characters for regex. So what this means is anything in between the opening and the closing bracket, it can have one character within those two brackets or more characters, right? So what the problem is here, it's greedy. This is a greedy match, because if you take a closer look at the HTML here, it starts off with an opening bracket, right? But also it ends with a closing bracket. In between, there are other characters. So this thing will match this entire text as a whole, because that's greedy. But maybe that's not what we want, right? That's not what we want, right? So how do we then utilize lazy matching? Well, we'll add on a question mark. What does this do? Right? So what this does is, so there's a dot, there's a plus sign. So this can happen. So these two mean one character or many characters, right? That's what it means. But that itself is preceded by a question mark. What that means is, well, that could happen once or like 0 times. It can have 1 or 2, like 0 times. Now, in this case, it would match everything that encloses it, like this one, all of them that have opening and closing brackets, right? So you might want this to just strip the, these HTML tags out of the text that you have ingested by scraping, right? And then you only want to have like the actual text in the HTML page, because these don't mean anything, right? Well, they do mean something in Markdown and in HTML, but they don't mean anything in terms of meaning, right? Meaning of the word itself. They're just there to, make it bold or italicize it and stuff like that. But that's the meaning of the words inside. So that could be the reason that you're matching them later on to strip them off and have only the meaning of the word itself. So let's see the output of these two. So the greedy matching, it matched, as I told you, the entire text, opening and closing. The lazy one, as you can see, the one that it matched is the B tags and the I tags. Okay? I hope that makes sense, okay? So as small as possible. This means as small as possible, okay? Just think of it that way. It can happen 1 or 2 times, but as small as possible, which means basically if I add here, I don't know, div elements, right? So if I run this one, as you can see, div is also captured, because I said one or more times this can happen, but as small as possible. Don't just match the entire thing. Don't be greedy. If you find smaller ones with enclosures, do like match those as well, okay? That's what it means. All right. Let's quickly move on to custom characters, classes, and negations. Yeah, we'll take a little bit of our time from the next session because we have to go through this as fast as possible, okay? Since I'm going to be sharing this itself with you, you can finish everything that's left out in these notebooks by yourself. There's explanations on them. I made sure that those were generated properly, so you can rest assured that you can just follow each one of these cells and the explanations as well, and you'll be good to go, okay? I think there's one thing that I wanted to raise. I think I found something. I think it's this one. In your notes, I believe. The PDFs that were shared. Yeah, this one, there's a typo here in the quantifiers and repetition section. You'll find this on Athena. It says here, the last one, we just saw this, right? So this says, we know this one means n times or more, right? So at least n times. And then the explanation says, matches the preceding element at least n times. And then it says, but not more than m times. This is a typo, okay? This is not true. That would be the case if it was n and m. However, if it's just only n, it doesn't mean this one, okay? Just take note of that. But the example is actually correct. So this is just a typo, I think. Okay. Yeah. Okay. Custom character classes, like what are they? Okay, so these are the patterns that you can add into square brackets. Now, let's start off with a simple example, ABC. So what this means is it matches either A, either B, or either C for a specific position in the word itself, right? One character. So it can be A, it can be B, it can be C, either one of these three. If you want to match a lowercase letter, just one letter, okay? These all are like one letter matches. If you want to match those, you would use a dash. If it's a dash inside of square brackets, then it means like the entire range between A and Z in this case, okay? Or the entire range between 0 and 9. Or here, the entire range between capital A and capital Z, okay? So this would match the entire lowercase character, but one character. Same goes here. 0 to 9 matches all digits, and take note of this also. It means \D. Don't worry about this one. This is a typo. You don't have to have like two double backslashes, okay? Or what you can do is if you want to match a letter or a digit, regardless of the casing, A to Z with small letters, a capital letter A to Z. So this is how you can mix those three, right? There's no space in between them, okay? No spaces, just you use it this way. All right? How about matching except, right? What if you don't want the character to be either A, B, or C? Not any of them. Instead, it can be anything else, 0 to 9. It can be, no, actually not 0 to 9, or anything else, yeah, anything else except A, B, or C. You use the caret character at the beginning of the three letters and like this, or it can be anything. It could also be a range here. Like you can say A to Z, capital letters A to Z should not be included to match a single character. That also works, right? So basically that means a negation. Okay, let's see these in action. So match the vowels, for example. A simple example here, Python data science. Vowels. So what you can do is you can use, so I'm always forgetting the names. Character classes, sorry. You can use character classes like this. And you can say, for example, for the first half, all the small letter vowels. And for the next one, you can have like all the capital letter vowels, in which case everything will be matched. We don't have any capital letter here. That is a vowel, but I guess it's good to have it. Now this would match the characters only. This is just one character, okay? This is trying to match one character, but it has to be either one of these that were listed. On the second one, match all the consonants with a negation, right? So consonants, you can use a character in front and all the vowels, in which case they will not be matched. Anything else other than the vowels will be matched. In our case, it's going to be consonants. And followed by, this is a white space character, right? It could be a tab, it could be a space, anything else, right? What that means is there has to be a white space at the end. No, sorry, not white space, but white space is part of the search here, okay? White spaces cannot be part of the matching, okay? Take note of this, it's very important. All the A, E, I, O, U vowels, regardless of their cases, will be negated and matched, right? Which means they will not be matched, but also a white space will not be matched, in which case all the consonant letters will be matched. If I didn't have this white space also here, then it's not A, E, I, O, U, right? The white space is not A, E, I, O, in which case it will try to match it. That's the problem, okay? I'll show you how that is. So match words, word characters and underscores, right? Let's just run this one. Okay, vowels in this, you can see the vowel characters themselves. As I told you, it just matches one character. Consonants, this one, right? It just outputted all the consonant characters out. Had I not added this space, white space character, if I ran this, you will notice the spaces are also matched, which was not our intention, right? Spaces are not consonants, so we have to add that as well here. So one thing you have to take note of is you don't have to know earlier on when you're building your regular expression. By the way, it's regular expression is kind of like itself is a program. Like you're coding it. You have to test it iteratively. Okay, it has to be tested and tested and tested. The problem is, we're humans, we make errors, and it might work for only one type of string, but when you try it on another, it gives you a different type of value, right? So always test your regular expressions. There might be some things that you're missing as well. You can ask AI to write you a regular expression, and yet it itself can make a mistake. Once you hit that token limit for the context window, it begins to forget some stuff. So over time, if you're speaking with AI for long periods of time, it can actually hallucinate and give you an erroneous type of regular expression, because regular expressions are quite difficult for an AI, at least at this time, if it begins hallucinating after a long conversation with an AI. So, you have to always test it. That's what I wanted to say. Okay. All right, so that's that. We'll take a look at grouping and move on to the next session. Okay. So grouping and capturing, this is important. So you can group patterns together. So parentheses is how you use groupings. So these parentheses actually do two things. The first one is they group your patterns together. Means, for example, for this one, A and B plus means AB repeated, right? not just B only, but A and B grouped together. They have to be repeated, right? So it could be AB or AB, 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 like as much times as it can show up in the string. That will be matched. That's one. The second one is create capturing groups. So this gives you an exact specific parts of a match. We'll see these in detail later on. So types of groups, the first one is a pattern. So the syntax would be just you give it a pattern within your normal brackets. Capturing group, this is it extracts this part only, the captured group. The next one is you use a question mark pattern and a colon and the pattern itself. This is a non-capturing group, so group but do not extract. This is meant for performance purposes, for Python, that is. The next one is named capturing group. You can name the captured group itself so that you can reference it later on when you try to extract the value out, right? And back references back to like 1 and 2. So let's go over the example here for grouping. Okay, basic capturing. What we want to capture here is the date. Okay, here you have date colon the date, right? 24th, 0315. Year, month, and date. Okay, now I will use the search here, search, because I'm using it with the group. Okay, find all would also work, but search is much better. So R with these three groups. Okay, they are not named groups, as you can see. They're just normal groups. The output of this, the output of the match is going to be a list of tuples. You should know by now what tuples are. Okay, so they're kind of like lists, but you kind of repeat within them. So here what we're doing is in the first group, so this is actually separated by a dash, okay? All groups are separated by dashes. In the first group, I have digits with multipliers, right? This is a multiplier, which says like exactly 4 characters of digits, right? 4 digits within the first group, that is. So that will match, in our case, the year. There's nothing else other than that, because this is 4, of course, but it's not a digit, is it? So that will not be matched. And then it will be followed by a dash. Like literally, it will be followed by a dash. Okay, that's one. The second group is a digit with two numbers. Again, that's repeated on the third one. From text, we are extracting it. Okay. Now, if we have a match, let's try and print it out. Okay, so let's print out the entire group first. We have 3 groups, as you can see, right? 3 groups. The first one would be a year. So I will access the group using the index. Here again with the index and here again with another index. So we have 3 groups, we have 3 indices. So first one would just print out a list of tuples. Sorry, if you say group and you call the method, now I understand. If you call the method, then the matched group is going to be returned, okay? If you only print out the match, is that you would get the tuples instead. All right, so here, the first one is, as you can see, 2024, the second one, the third one. All of these 3 have been saved inside of my match, right? That's what's happened. Let's print out match as well here. So it's a match object. Oh, this is because it's search, actually. Let me change this if I can to find iterating. Oh, this is the iterator. Yeah, okay, so yeah. In which case I'll have to use, I think, iterations here. So for match in matches, yeah, I have to say matches here. Let's print out match if possible. No. Yeah, I think we'll see maybe like how iter works later on. I seem to have forgotten it. But you can rest assured if you use search and there's a match, what that means is that the values themselves have been extracted and put into the match object. Okay, in which case you can reference each one of them using the group method of match object. As you can see, it's an object. Let's print it out once more here. Right, it's a match object. And the match itself is this one, right? So 24 this. So it has its own methods. Objects will have their own methods in your previous object-oriented class. You should know this. Objects are created out of classes, and those objects will inherit the class's methods and attributes. That's why we have group here, giving us the values for each one, right? So internally, group is actually a method which we pass values to, and it will extract the value internally saved. And this match itself is holding our data, which is this date itself. Okay, capturing groups with find all. I think this is the one. So if you want to capture groups, for example, in this case, we want to extract an email, right? Or emails, multiple emails. It says contact this, or so this happens always in scraping. There's a lot of emails that you might want to output, or any type of like PDF files or all of that. Okay, so without groups, you get whole matches. So without groups, you can just use find all. You can actually match it this way, which is quite easy to match like an email address using a regular expression. A to Z as a starting point, right? So this tries to match the first part of our email, which is the username, I guess. But I can also add here capital A to Z, because it might be the case, but it doesn't matter, right? You don't care if emails are capitalized or not, right? They would work. So that's why you can use A to Z like this. But notice there's a plus here. This is just matching a character, one character, right? It could be anything A to Z, but it has to happen one or more times before the call for the @ symbol, right? So that's what we get here. Yeah. And we literally match the @ symbol. That's okay. Literal matching. And then after that, again, A to Z, but we want to match also the dot as well. Here, the dot, this is important. If it's in the square bracket, it's considered a literal dot. And then there's a plus here for the rest. I wouldn't exactly make it this way. Instead, I would also add here a dot. So this is a dot here, but I would not do it like this. Let's see, actually, it will work right now. But okay, let's first finish everything. So if we just try to print out everything that matches, then, we match this one, we match this, and this, all three of them. With groups, right, we can create groups like this, and let's see what the output is for this one. So we have a group for, the first group is going to be for the username, the last one for the email provider, I guess. And the rest of the TLD, which is .com, .org, are those. So without grouping, we're matching the entire email as a string. However, if we want more control, as you can see here, find all actually returned for us the one that I just forgot how to return, which is a list of tuples, right? A list of tuples. So it should have been find. I think this, yeah. If I change this to find, then I've gotten a list of tuples. Find all, sorry. Right? So it matched it. And each group is extracted to its own tuple, as you can see, right? Its own tuple. So this one So the whole regex matched Alice at example.com, but also it has a group. So it grouped it, leaving the at symbol because it's not part of a group. We don't want it. So we left that out and we have Alice and example.com, Bob and test.org. If we want to take this a little bit further, we could extract also the TLD, top level domain. By this can be a plus. And then there can be a group here. Or I don't need the dot, so I'll say dot. But the problem is I'm trying to literally match the dot, which in this case it will not work. But if I do a forward backslash, then this should work. And then however many characters, A to Z, after that, like this, right? So if you run this, the dot is not going to be included. However, Alice, example, and com will be matched accordingly, right? Same goes for the other ones, right? So Alice's is a .com. Bob's looks like a work email. This a normal email. That should, so like I don't want to. Yeah, I think I can work also with square brackets somewhere. I think that should work as well, right? Yeah, it did work actually. So yeah, you can do it this way also, like in the middle of these two, which is the domain and the top level domain. You can add in square brackets a dot, but yeah, I mean, it's cleaner to read this way. I mean, if you see the regex itself, it looks cleaner, right? That's one thing also you have to take note of. Your regexes need to be clean to read. They should not be very complicated. But you can, since this is a group as well, instead of having a lot of squares, you can just escape the dot character like this. This is also cleaner. I mean, it's okay. You know, it's readable. This can work as well. All right. Yeah, I think the rest of the stuff is advanced anchors and boundaries, Python's RE module, and all of the capitalized attributes. These seem like an attribute because they're not exactly methods. You have function, search, match, find all, find, iter, all of those. So I will leave the rest of the stuff here. I think there's also one for, practice exercises here. And string manipulation with pandas is also here. And I believe, there isn't any exercise here. However, I do have an exam also an exercise. I think this is the one. Yeah, exercises like this. No, not this one, sorry. Regex exam, yeah, this one. So this one is great. Let me just clear all the kernel. This. And this is just only the questions are the first ones. And then once you finish the questions is when you see it says stop. You have to first finish everything and then you get to see the solution later on. Right. So this is like about like how many questions is this? 34. Okay, 34 questions, 34 answers. I'll make sure that is shared with you guys as well. Okay, let's move on to the next session, which is an important one. Yeah, I believe this is yeah, exactly. Okay, so this is also a very long one actually. I think I have to clear every cell out first. Great. Okay. So it starts off with module 0 just to give you an understanding of how why do we need visualization first? The common namings of some of the operations that you do when you visualize, like max, min, the median, the standard deviation, the distribution curve, the correlations, the regression, all that stuff. We'll try to explain those first and then move on to matplotlib and Seaborn. I'm not sure if I have an exam for this that you can walk through, but I'll make sure that I generate it. It's okay. And share it with you guys as well. All right, so the libraries that we will be using here, Seaborn, Matplotlib, Pandas, and NumPy. Two of these are visualizers. The others are just working with data, 2D and 1D data, even more than two-dimensional as well. Okay, just to make sure everything works, we'll run this one. We need NumPy, we need Pandas, we need Matplotlibs, PyPlot, renamed, and Seaborn, also SNS, renamed. And we are changing the style here for Seaborn. You'll get to understand when you go through this notebook, like why do you use this? It's just visualization stuff, so don't worry. For the matplotlib, we set the figure size of this much amount, 10. I believe this is the number of columns, and 5 is, I think, number of rows. Don't quote me though. All right, so the first thing to start off with is statistical foundations. We need to understand these because we'll be using most of the plotting libraries, plotting methods in Matplotlib and Seaborn to basically operate on statistical things, right? Like min-max, mean, medians, standard deviation, the bell curve, the correlation and regression, right? So what are these? If you don't know them, you cannot just plot them, right? So you don't know how to also manipulate the tables and understand an output of it. So let's just get started. I know you'll be having a session on this, not session, but a week for this, but just like an introductory one wouldn't hurt. All right. Okay, so let's start off with the first one, min and max. Very easy. In a normal one-dimensional array of numbers, you will have minimums and maximums, and then the range. These are the three things you will have as the number values, right? So the minimum is obviously the smallest value in that series. The maximum is the biggest value, and the range gives you the difference between the minimum and the maximum value. How far apart are those, right? That's what it gives you. So let's give a real world analogy. So imagine you have like 10 students. How many hours they studied last week? You have that data, for example, 1, 3, 3, 4. This one is your series. How many hours did they study, right? Each one of those students. Now, the minimum value, you can just see it, it's 1, right? 1 hour study last week. The maximum is 12 hours study. So the range is 12 minus 1, which is 11, which basically means there's a huge gap between the person who spent a longer time studying and the person who spent very small time studying, right? So there's a huge gap. So what that tells you is range tells you how spread out the group is. So range of 11 means there's a huge difference between the least and the most dedicated student. That's basically what it tells you. All right, so how do you plot it? Plotting, we'll see them later on, but like you can create a NumPy array like this using Python list. You can print out the array itself if you want to. The minimum, you can use .min. NumPy has this option by itself, minimum hours, maximum hours. And if you want to see the range, just subtract max from min. Sorry, just subtract min from max, and then that gives you the hours, right? All right, so how do you plot it? So let's create here a subplot. Subplot means within a paper, one area is dedicated for a subplot, right? So you can have multiple plots within one canvas, right? And also a way to extract the the canvas to draw onto is using this destructuring, okay? So the figure can be extracted, which is the main canvas, and also the place that you want to put it to. So the subplot has a size of 10 by 3. This is the fig size. So what we want to plot here is a scatter. Okay, you'll see this is a one-dimensional data, so scatter is not going to be difficult to read. So AX.scatter, study hours, the original array will be provided. So mp.zeros like, so study hours, and S22, and so these are just the attributes actually. So edge colors black, color line width, these are just attributes for the scatter plotter, right? So you can add lines inside just to see how they look. So the minimum line, the max line, so you can give them Hi team, can you hear me? Can you hear me?
Yes, I can hear you. I can hear you.
Awesome. Sorry, I just lost power. Sorry for that. Let me see. Okay, you can see it. Somebody said they cannot see this. The font is very small. Okay, so let's finish this. I think get rid of it. Awesome. Okay. Great. Good. Okay, so this axis V line basically means the maximum and the minimum lines will be drawn on the axis. So let's just see this. I mean, the drawing is not something that we are interested in, at least right now. We want to see maximum and minimum ranges, right? So let's just play this one. All right, so there are some outputs in this. We have printed the study hours, right? The minimum hour, the maximum hour, 12 hours, and the range is 11. So the drawing here, it gives you, a view of how spread out it is. So this is a scatter plot for one-dimensional data. You can see the range here. There's 11. The maximum and the minimum are drawn here. And this is how your data looks like, okay? So what to notice is that every blue dot is one student here, okay? There's a 1 value here, there's a 3 value here, 4, 5, you got 2 5s here, so it's overlapping. You have 6, you have 7, 8, and then 12 later on, right? So this is the maximum one. It's on those lines, the maximum and the minimum lines are, showing up, right? All right, we're good with this one. Let's move on to the next one, which is the mean and median. Okay, what does it mean exactly? Like, what do we mean by mean? Mean is just average. It's a simple averaging calculation. It gives you a single value. And what you do is you just add all of the numbers, multiply them to the size of your series. In our case, our min is sitting at 5.4 here. Okay, it's very easy, right? Let's move on to the median. What is a median? Median is sort of like the same as mean, but before you calculate it, the series has to be sorted in ascending order. After you sort it, then you extract the middle value of that, right? In our case, we have about like 3, 6, 9, 10, 10, right? We've got 10 entries in our series, which means there is no middle element, right? Per se, there's a middle element here. The only middle element that you see here are two, if you take two of them as one. What you do in such cases is you add those and create an average of those, and that's your median value. Had this been like 11, 11 elements in my series, then I would definitely get the mid value, right? It's quite easy to do that. So here it's 5. 5.4 for mean, 5 for median, right? So what's the difference between the two? Not so much, but you get to see that if there are outliers in your data. For example, if a person took about like 100 hours last week learning, right? 100 hours, which is a lot of hours, right? Learning, that's an outlier, in which case the mean value is quite hard. All right, sorry. Okay. It's just that because it flows over my width of my laptop that I don't zoom in, but I will just zoom in to the proper places. Okay. The water break, sorry. Okay. Sorry for that. All right, so here, let me just close this one. All right, so let's see an example of how these two correlate with each other. Let's have a scenario of an employee salaries at a small company. We have an array of these numbers, right? They're comparably similar. They're close enough to each other. In which case, if you calculate the mean and the median value for both, it's much more likely that those values are comparable, equal to each other sometimes, or close to each other, right? However, if you append one more row in there, that's a very big number, which is an outlier value. What happens is your mean value would be dragged to the highest point, right? It will drag that value. So an outlier would affect the mean value, but the median would stay the same all the time. So how do you calculate that? Well, you can use numpy.median for calculating the median, numpy.mean for calculating the mean. So if you run this, so if you don't add the CEO's salary, mean and median are basically the same. If you add it though, you can see the mean is pulled dramatically to a higher value, which doesn't tell you about like a good information, but it's actually a good idea to calculate both of them and see their difference, because it tells you something about your data. If the mean is higher or lower, and it's significantly higher or lower than the median, then that means your data has some outliers. So you have to take note of that. So visualizing mean and median values using a histogram. Histograms are like bar charts, but for like a range of data, not exactly like particular values for the bars themselves. So if we plot this, I think this is for affect the average. Okay, this is the same data set, right? So let's use that one and print that out. So let me zoom out here. All right, so you can see here, we've just drawn our mean and median values. You have a legend here. So without the CEO, you can see this like there's a 19,500 person. The highest is 2,100, sorry, 21,000. But the values, both of them, the mean and the median, are on the same bar, right? On the same bar at 21,000. However, if you add the salary of the CEO, you can see the changes, right? It's outside. So if you see this one, also, it's from 0 to 100,000. This is the salary limit or range. There's a gap here you can see. single gap between 0 and the starting point of the bar, and there's another gap between 100,000 and the end of this bar, right? So if you add both of them, you would think that this bar itself takes about like 1/3 of the entire width here. So if you divide 100,000 by 3, divided by 3, you would get 33,000, right? So this one bar itself, from starting to the end, it is spanning like 33,000 range, right? From 0 to 33,000, or from some point to 33,000, right? But this is not the same. These are just the same value. So there's an outlier. It's outside of the bar. That's how you can see if your data has outliers. Okay, histograms. Okay, histograms. Okay, the other one is standard deviation. In standard deviation, sorry. Yeah. So means standard deviation tells you how spread out the data is around the center value. The center in this case could be median or mean. Most of the cases average. So a lower standard deviation means values are clustered together to one value, and that value or the number of values within that one bar is actually a lot. Okay, it's very lot on the y-axis. If it's a higher standard deviation, it's spread to the side. So you'll see that in the bell curve later on, how spread out it can be and how you can plot it as well, right? So higher standard deviation is how the data goes from the mean to one side or the other, like left or right, okay? So if you have like a standard deviation value of 5, then that means from the mean or from the average value, 5 to the left side or 5 to the right side. So just as an example here, so let's have two classes, say mean. So let's create two classes, right? A and B. So these are just going to be for, let's say, class A and class B. So imagine that you have students in class A and class B, in which you have like scores, the scores of their exams are for class A, 60, 62, 65, up to 70. For class B, you have 20 up to 100, right? But the problem with this itself is the average for both of them is actually 65% if you calculate them. But there's their spread, right? You have someone who scored 20, you have someone who scored 100, 90, 35. But if you see the class A, there is no spread, right? It's around 65. It's around the average value. So this is what we mean by a lower standard deviation. There is no deviation, or there's a very small deviation from the average value, right? However, this one has a higher standard deviation. So if you calculate this one and plot the graph for this one, you would use a graphing of histograms, all right? Hist. So you would see this. So for class A, there is no spread, right? The standard deviation is calculated to be about 4.6. So 4.6 from the average value plus sorry for that again. Yeah, I think you can see my screen now. Please just tell me if you can. Thumbs up or down. me see. Can you hear me and also see my screen? Okay, awesome, awesome. I keep getting disconnected because of network. Sorry for that. All right. Okay, so we're here looking at the standard deviation, right? So this is how you would see standard deviation and how you would plot it in histograms, okay? So that's histograms being used for standard deviation. The next one is the distribution and the bell curve. So the standard deviations tell you the value. The distribution or the normal distribution of the bell curve shows you the graph itself, right? Okay, so this describes how values are spread across a range, where they cluster, or where they thin out, and what shape does that pattern take, right? It doesn't have to be an exact bell curve, but in most cases, when you find in real world, if you take large enough data and you try to see the distribution curve, it's most of the time it's the bell curve that you see. For example, it could be the height of every person in this world. If you calculate the whole height, like the standard deviation and like the normal distribution, it would look like a bell curve, right? You see this everywhere. For example, height of people, exam scores, even measurement errors in instrumentations, in metrology labs, crop weights, even natural occurrences, crop weights, right? So birth weights, when babies are born, how much do they weigh? Normal distribution again, right? So that's what you see here. So let's see this. This is also a hist, I believe. We're plotting using what exactly? Yeah, a histogram, right? So if you run this one, this is what you see. This is using, by the way, SciPy, which is outside of the scope, but it's great to see, right? So this is the bell curve, right? It looks like a bell. And the standard deviation is, as you can see here, about like ±1, which is, I think this is, yeah, so the standard deviation is 7.9. This is for, a random height that was generated. It's not exactly a real data, but random heights generated. Now, the mean height is 1.69, right? 1.69 is right here. And the standard deviation between like left and the right side is 7.9C, right? So 162, no, sorry. Yeah, 162 to 178 or so is the area of the standard deviation, which you find most of the people, right? And if you just use +1 or -1 standard deviation, you get about like 70% of the people in that window, which is crazy, right? So just only like +1 on this, like 170, right? 170.6 and 168.6. Between those two values, you can find 70% of the world's population's height within that range. So I guess that's what it's saying here. But okay, again, for bell curve, you use histograms. Another one is correlation. Correlation measures whether two variables move together. If so, in which direction are they going? So there's positive correlation, there's negative correlation, and there's no correlation. So a positive correlation would be, for example, study hours and exam scores, right? So the more you study, the higher your exam scores will be, right? Unless you're burnt out and there are other aspects. In the general sense, if you study more, your exams will be better, right? But that means that's a positive correlation. And to some sense, you can think of it as causation as well. Causation means the change of variable 1 is affecting the change of variable 2, which means the change in the number of study hours increase will affect the exam score to increase. So there's some sort of causation there, right? Negative correlation means one variable increases, the other one decreases, or vice versa. So for that, a perfect example is, let me see. Exactly. Two-way causality doesn't work in exam scores. Yeah, actually it works. Yes, exactly. Okay, negative correlation. A perfect example is the price of a car in a functioning economy. There are some economies that are not functioning well, in which case you may not get negative correlation, but you might get no correlation. But in a well-working economy, the price of a car, buying a car is a liability instead of an asset, which means if it's an asset, the value would increase, right, over time. If it's a liability, then the value decreases over time. Now, price of a car and its age is a perfect example for negative correlation in a functioning economy. So as the years increase, right, as the number of, like how old the car is, if it increases, then the price of it decreases. That's a negative correlation, right? However, that does not mean it's causing it. There's no causation here. It's not because of the years increasing only that the car's price is reducing, right? I mean, if you just put the car in the garage and never drive it, even after 5 years, you could sell it with a good, because it's 0 kilometers driven, right? So the graph is not going to show you like a negative, exactly negative correlation. It might show you like no correlation sometimes, positive. It depends on the car. I mean, if it's a Ferrari, then it could be an asset, right? So that's a negative correlation. Just in a general sense, price of a car and its age is a negative correlation. And when it comes to no correlation, the two variables have inconsistent relationship. For example, one grows, the other one could go down sometimes, could go up as well. So there's no correlation there. Perfect example is like, let's say, does your shoe size affect your exam scores? Right? Does it affect you? I mean, it doesn't, right? There's no correlation. I mean, unless there's something that we don't understand about this universe. Shoe sizes should not affect in any sense your exam scores, right? So that's no correlation. Your shoe size over time will increase if you're a kid and then you're growing up to be a man or a woman. However, your exam scores would go up and down every time, right? That's just what's going to happen. That's negative correlation. No, that's no correlation. So for that, you can plot it in a, I believe it's a scatter plot. Yeah, it's a scatter plot that you can use here, which will show you a better understanding of how two variables grow with each other, right? Excuse me. So you have, I'm not sure what the example is for this one. Ice cream sales and drowning rates are positively correlated. They both go up in summer. Okay, ice cream sales go up because it's hot. And that does not mean eating ice cream causes drowning, right? So drowning means like, drowning in water, right? So, but ice cream sales could also increase in summer, but like people could also go to the beach, right? Who knows? So just as an example, we're seeing positive correlation should look like a positive y-axis trend, right? It's a trend. You can think of it like a trend line. So it could, X increases, variable Y also increases, and you see this type of correlation, right? There's also some types of like noise, as you can see, but there's a positive correlation. As one increases, the other one is also increasing. The other one is negative correlation. As one is increasing, as X is increasing, Y is actually dropping down. This is a negative correlation. This is a perfect example for the car example. And no correlation is this one. The shoe size is not exactly a good example for this, but there are a lot of examples, right? Right, so this would be using a scatter plot. Regression, this is draws the best fitting line through a scattered plot, right? Like this one. So the best fitting line will be drawn. So if correlation answers these two variables move together, that we know that it answers this, right? Correlation answers this question. Regression, what does it answer? If I know X, what can I predict about Y? That's what you get by regression. It's basically prediction. And here also, I think you are going to be using a scatter plot. And I think also it's going to be accompanied by a line. That's from this one. Yeah, exactly. So this is the regression line that's going to be drawn on the scatter plot of our two X and Y. So hours studied and exam score, this is how it spreads, right? But you can see the regression line is this one, which is positive, right? Positive regression with a slope of a positive number, right? Higher regressions means basically the Y side is growing faster than the X side and vice versa. Okay. All right, so as a recap, these are the things that you need to take note of. These are the things that you're going to be using to draw and use it in your visualization. Now, why do you want to visualize data? Well, there's an example about Anscombe's quartet here. The reason why you want to plot instead of just seeing these summarized versions like the standard deviation, the correlation, the mean values only, they won't tell you the full picture of your data. You have to see it in visually to see if maybe like two data sets are similar or not. Because sometimes you get, if you remember earlier, class A and class B had the same average value, right? 65% was the average. However, the standard deviation was different, right? But sometimes you might find the mean being equal, the standard deviation also like comparably equal, and also correlation, right? In which case you might feel like, oh, wait, these two data sets must be similar, but they may not be. That's what you're going to be seeing here as an example. Anscombe's quartet. So we're going to create a data frame from pandas using a simple dictionary that has values for x1, y1, x2, y2, x3, y3, and x4, y4. Now, if you take a look at those closely, x1 is this one, right? If you take the mean value of x1 and the mean value of x2, which is the average basically, they're similar. So I can just run this one for you and show you. So for data set 1, which is x1, right? Mean of x is 9. Data set 2 is also 9, if you calculate all of these. Now, you see that mean x, mean y correlation, excuse me, correlation is like comparably similar, right? All the way. Now, this will give you a false sense of assurance that these x, y, y1, x2, y2, x3, y3, all of them are this similar, right? But look at what happens when we try to plot this. So what we're going to be using is scatter plots for all of them because they're x and y, right? Let's see what's going to happen, right? Scatter plot. The rest of the stuff is just beautifying the graphs. We're also creating subplots within a figure, which means like we're going to have 4 sections of the graphs drawn for us. So let's just see this, right? I just ran this. Okay, so this is our answer. You can see how different they are, right? This looks okay-ish, right? Not exactly okay. But look at this one. This is a parabolic, what is it? Like a scatter diagram. The relationships basically, right? X and Y. Look at this one. It feels like the regression, it's following the regression line, but then again, there's an outlier here, and that outlier is pulling the regression line upwards. This is completely different. It's not correct. And so same regression line for all of them, as you can see. The regression line is actually exactly the same. However, the plot is different for different stories, right? So that's why you don't have to, or you should not rely only on these statistical values. You should instead work with plotting, okay? I think we are running out of time now. So module 2 goes over most of the plotting fundamentals, and also I have a matplotlib and seaborn only like crash course. So it's going to be like a 90-minute crash course that you can take just from the setup all the way to begin visualizing, right? Here like this. Line plots, how can you plot lines with two lists like this? You can just use two of these lists, X and Y, just plot it. It's very easy. You don't even have to use these. You can just run this one and you can see the output. So all of these are just exercises, okay? Just going to leave this one back that you guys can go through. Sorry, I couldn't finish today's last session, which is the plotting side. But I hope these notebooks that I'm creating for you are going to be helping you out. I'll make sure that I will cover more on our next session. Let me just make sure by yeah, Buhari, do you think we can maybe like spend 5 more minutes, or do we have time?
Okay, I didn't get you. What do you say?
Do we have maybe like 5 minutes, or should we be closing it now?
Okay, based on the time, I think it's 1 minute, so maybe you can quickly round up.
Okay, we may not have time, so let's just close it by this, and instead I'll be sharing most of the notebooks with the learners on eHub, and I'll make sure that I communicate with John to make sure that happens. Okay, so thanks guys for joining me today. We'll continue, I think, next week with the continuation of this or other concepts. So if you have any questions, please do reach out to us, and take note of the guide, the assessment guide that Segun mentioned earlier, so that you don't have any issues. There are certain things that we are going to be clearing out on Athena itself, hopefully. But until then, the assessments are going to be helping you out a lot. And one thing that I want to raise is please make sure that you take into consideration that you exercise a lot. These notebooks are very good. I mean, for me, I don't exactly use like Jupyter notebooks per se, but like the way they work, it's very nice. The only way I know it is just opening Python on the terminal and just interacting with it. But this is very good. So notebooks are very good. You can delete, you can mess with them, nothing would happen. So just make sure that you exercise more on those and use heavily AI also in your learning, okay? Just to learn, not to answer. Just be smart about that. If you ask it to answer it, then like, where is the learning? You want to know something, not just, give an answer for it. So just let it guide you through the way of like thinking about stuff, right? About like how to plot stuff, the statistical parts of it and stuff like that. So yeah, do that and you should be good to go. Thanks for joining me today. I hope you had a great time, and see you, I guess, next week. Thank you. Yeah, I think we raised this one. Awesome. Okay. Hi Segun, can I
Yeah, you can
stop
end it.
the YouTube live stream?
Yeah, just you can end the session. You should see at the bottom right, end the session.
Can you hear me?
Yeah, I can hear you.